Work on the Pythagorean theorem. Here's our triangle. There's a right angle. This side is 6. This is 8. And we're going to be solving for x. So we know the Pythagorean theorem is a squared plus b squared equals c squared. So for this problem, 6 is a. So we're going to do 6 squared plus b, which is 8 squared, equals c, or x squared. So we're going to plug that into our calculator. So c squared plus 8 squared equals 100. So now we're going to have to find the square root of 100, which is 10. So x equals 10. Okay. To the next problem. Alright, so for this triangle, this side is going to be 5. This side is 4. This side is x. So we're solving for x again. So this time we know that 5 is the hypotenuse. So it's going to be, so remember our formula is a squared plus b squared equals c squared. So if 4 is a and x is b, then 5 squared, we're going to have to subtract 4 squared from 5 squared. So 5 squared minus 4 squared equals 9, and the square root of 9 is 3. So x equals 3. Okay, so our next triangle, there's the right angle. This side is 45. This side is 36. This side is x. So we know that 45 is our hypotenuse. So we're going to do 36 is a plus x squared, which is b, equals 45 squared. So again, we're going to subtract 36 squared from 45 squared and get our x. So that's 729, and now the square root of 729 is 27. So x is equal to 27. And that is our answer.
So today we're going to be talking a little bit about how to find the opposite, adjacent, and hypotenuse of a triangle, because these are integral to know if you wish to solve anything using SOHCAHTOA. So I'm going to draw us a nice little example triangle over here. And of course, it's going to be a right triangle because that is required to solve anything using SOHCAHTOA. So let's say this is triangle A, B, C. And I want to find the tangent of A. Okay. Well, of course, if I know SOHCAHTOA, I know that to find tangent, I have to go down here to TOA, and I see that it's opposite over adjacent. But what are opposite and adjacent? Well, that all comes down to what angle, or well, what side I'm trying to find the tangent of. And I come back up here and I see A. Okay, so I know that it's going to be opposite of A. And this would be the same if I asked for the tangent of B. I would go for the opposite of B. So I look over here, I see A, and I say, okay, well, what's the opposite of A? And I'll draw in some things for us right now. So let's say that's 12, 10, 7. Okay, well, I can look here and I can see that right across from angle of A is 12. So I know that that's my opposite. So I have 12 over, and then I look and I say, okay, well, what's adjacent to A? Now, the adjacent side can never be the hypotenuse. And this is my hypotenuse since it's right across from the right angle. So I know it's not 10, which means it must be 7. So 12 over 7, that is going to be my opposite and my adjacent. Okay? Hello. So I'm going to be helping to teach you a little bit of SOHCAHTOA. So our first problem here is this nifty little triangle. I'm going to draw him in blue because that just makes me happy. Yep, just give me a second to draw him, and you can think about your favorite triangles while I do this. Yes. So that side length, BC, is 48, BA is 14, and AC is 50. And B is a right angle. And now in this problem, we're trying to find cosine of angle C, right? So if we look at SOHCAHTOA, SOHCAHTOA, if we want cosine, we need adjacent over hypotenuse. So we look at this problem, and we know, of course, that our hypotenuse is 50 since it's opposite the right angle. So we know something over 50, and the adjacent angle, or leg, is going to be 14. I'm sorry, not 14, 48. I'm going insane. That's my fault. 48 over 50, okay? Now, this is definitely something we can simplify. So if I plug that into my calculator, we can simplify him down to 24/25, and then we can go ahead and plug him in. So now it's cosine of 24/25. And the answer to that is 0.99, but really 1. Okay, so cosine of C is 1. Now, we're going to erase all of that, and we can go ahead and just move on to our next problem. Okay. Okie doke. So our next problem is another right triangle, of course, because SOHCAHTOA, and ZXY is this triangle, and then ZX is 40, XY is 24, and ZY is 32. In this problem, we want to find the sine of Z. Okay, so sine of Z, let's think about this. So we have SOHCAHTOA, and if we want sine, that means we need opposite over hypotenuse. Now our opposite is going to be, since we're Z, the opposite of Z is 24, so 24 over the obvious hypotenuse, which is 40. Now this is definitely something that can be simplified, so we're gonna put him down to 3/5, and now we can put it in. So sine of 3/5 equals 0.01. Well, approximately 0.01. Oh, triangle ZXY. So we have our lovely right triangle, ZXY, and then ZY is 32, ZX is 40, and XY is 24. Okay, now in this problem, we want the tangent of X. So when we look at SOHCAHTOA, we know that tangent is given to us by opposite over adjacent. So X, the opposite of X is 32, so 32 over 24. And this is something that can be simplified into 4/3. So now we're going to plug in the tangent of 4/3, and that is going to give us 0.02. Okay.
Let's move on to special right triangles. So I'm going to start by drawing our first example. So with special right triangles, the legs are always going to be congruent in a 45, 45, 90 triangle. So if we know that this one is 2 times the square root of 2, we know that the other leg is going to be also 2 times the square root of 2. Now to find the hypotenuse, all you need to do is to take one of the lengths of the legs and multiply it times the square root of 2. So let's do that. So you have, let's just say hypotenuse x. So we can say that x equals 2 times the square root of 2 times the square root of 2. So we can do that in our calculator. So you can do 2 times the square root of 4, since you can multiply the 2's. And then square root of 4 we know is 2. So 2 times 2 equals 4. And that is going to be our answer. So let's continue on to our next problem. So our next problem is going to be this. 4 is the hypotenuse. So we know that 4 is the hypotenuse, and to get one of the legs from the hypotenuse, you need to divide it by the square root of 2. So we can find this leg by doing 4 divided by the square root of 2, but you can't do division by the square root of 2, so you need to multiply it by square root of 2 over the square root of 2. And then you can do 4 times the square root of 2 over square root of 4. And then you can simplify that to down here. You can do 2 times the square root of 2 over 2. It would be 4 times the square root of 2 over 2, which would end up to be 2 times the square root of 2. So we know that if one of the legs equals 2 times the square root of 2, we know that the other leg is also going to be equal to that. So that is going to be our answer for both of the legs. Okay, let's move on to 30, 60, 90 triangles. Now these are going to be a little bit different because you need to identify some parts of the triangle before you even start trying to find out the different sides. Let me draw our triangle. Okay, so let's start out by identifying our legs. So we know that this side, this little area with little square, is going to be 90 degrees. So this is going to be our hypotenuse. I'm just going to shorten it because that's a little bit too long to write. Since we know that the 30 degrees is right here, we know that this 2 is going to be our short leg. So I'm going to write that here. And then just by association, since this is our last side, this is going to be our 60, so this is going to be our long leg. So this one is a little bit different because you are starting with your short leg. So let's try to find our long leg first. So going back to our last problem, we had our short leg, and all we had to do to find the long leg is multiply it by the square root of 3. So let's do 2 times the square root of 3, and that's just going to be our long leg. So to get the hypotenuse from that, all you need to do is multiply our short leg times 2. So 2 times 2 is 4. So our hypotenuse is going to be 4. Our short leg, we already knew, is 2. And our long leg is going to be 2 times the square root of 3. So let's move on to our next problem. So, okay. Let me draw out our next problem. Sorry, I'm not good at drawing these triangles. Okay, so we know that this square means 90 degrees, so this side is going to be our hypotenuse. This 60 degrees means this side is going to be our long leg, and by association, this number 8 is going to be our short leg. So, since we already have the short leg, let's start out by finding the hypotenuse. So, to find the hypotenuse from our short leg, all you need to do is multiply it times 2. So, let's do 8 times 2, which is 16. So, our hypotenuse is going to be 16. And our long leg, to find the long leg from our short leg, all you need to do is divide by the square root of 3. So, let's do 8 divided by the square root of 3, but we know that we can't do that, so we need to multiply that times square root of 3, square root of 3. So that is going to be 8 times the square root of 3 over the square root of 9. Sorry. So that is going to be, it's going to be just 8 times the square root of 3, because square root of 9 is 3. Oh, sorry. It's going to be 8 times the square root of 3 over 3. And that is going to be our long leg. Sorry, I kind of ran out of room there. And let's move on to our last problem, which is going to be another 30, 60, 90 triangle. Let's do this one. So, okay, since we have our little square here, we know that the opposite side to that is going to be our hypotenuse, which we already have the answer to, which is 10. So this 60 proves that this side is going to be our long leg, and by association, this is going to be our short leg. So from the hypotenuse, to get the short leg, all you need to do is divide by 2. So 10 divided by 2 is 5. So we know that our short leg is 5. Now, to get the long leg, all you need to do is take the short leg and multiply it times the square root of 3. So 5 times the square root of 3 is our long leg.